Okay, on this lesson we're going to be looking at translating graphs. The objectives are to understand how an equation is made from a parent function, create equation using translation rule, and to understand vertex form and translation, how they kind of work together. Vocabulary for this lesson: the vertex, point where graph changes direction. Parent function, the most basic form of a function. Family of functions, functions made from a parent function. Vertex form, we have two vertex forms: quadratic, y equals a times x minus h squared plus k, and absolute value, y equals a, the absolute value of x minus h plus k. These are both going to be working with a values of 1 right now because our focus is on the translation of these graphs. To put this in the most basic idea, translating is really just moving the vertex. Now, this doesn't work per se for equations outside of these two parents, but in the basics that we're looking at just moving the vertex. It's really moving any point, but we focus on the vertex because it's the central point in these two graphs. So here we have the parent function of absolute value, y equals absolute value of x. This has a vertex of 0, 0. So if we go back to our parent function, what we have is y equals absolute value of x. We want to subtract the x value. This is h and this is k. I'm going to put that for all of them. We want to subtract the 0, absolute value it, and then add 0. And notice here how x minus 0 is really just x. Adding 0 really doesn't do anything. So here's our parent function. A family function would be, we're subtracting a 4 from the x. That would be our h value of 4 minus the 4. And add the 2. We've got a positive 2 here. This same pattern also works for quadratics. So y equals x minus 0 squared plus 0. Notice how minusing the 0, the h value, adding the 0, the k value, really x minus 0, just x. Adding 0 after squaring it, we really don't need that, so it comes back to this parent function, just like this one did. And our family is add 3. Well, adding 3 actually means that we subtracted a negative 3. Y equals x minus negative 3 squared and minus 1. Because it's negative 1, this would be adding negative 1. These become the subtraction. These become the addition. So that's why they look a little bit different there. So this is the basics of translating. It's really just moving the vertex, having a different vertex other than 0, 0 in the problem. So our focus when we look at the graphs to make an equation will be on the vertex in this case. So we're going to start with absolute value problems. And what we have here is we have our original parent function, y equals absolute value of x. Here's a table for it. Absolute value of negative 2 is 2. Negative 1 gives us positive 1. 0 gives us 0. 1 gives us positive 1. And 2 gives us positive 2. Creates this graph right here. Okay? And then we have a translated graph right here. This translated graph, we're going to look at how the vertex has moved. We can really look at any point. We focus on the vertex because it's our central point. It's really easy to find. So we're going to move, it looks like 1 to the right and 1, 2 down. So we're going to go right 1 and down 2. So in vertex terms, what that is saying is our new vertex is really 1, -2. Then we want to put this into our vertex form. So now that we have this vertex movement, we can say, well, our new equation is y equals, our vertex form is a, absolute value of x minus h, plus k. Okay? Now our a value right now is going to be 1, because that just makes life easier. Don't even need it if it's 1. Our x value, or our h value, is 1 right here. So we're going to take that 1, we're going to put it in here, and get 1. We're going to take our -2, put it in for k, and get -2. Adding a negative, we can really just rewrite that as subtraction. So we have y equals the absolute value of x minus 1 minus 2. Okay? We have this same idea for quadratics. What we have here again is our parent function, y equals x squared. -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. This creates this graph right here. Again, we have moved our graph over. This is our parent. We created one of the parts of the family right here. We've moved the vertex. The vertex is easy to find. That's why we focus on it. Again, we can use any point. We focus on the vertex. So we want to see where it is moved. Then we know where the vertex is. Then we can create vertex form. 1 looks like 1 up. So up 1. And 1, 2, 3 left. Okay, now the x value isn't the up, it's actually the left, so we need to focus there first. So we have a -3 because left means negative, and we've got up 1, so that's got to be a positive 1. So now we have to create our vertex form, which is y equals a times x minus h squared plus k. Okay? From here, what we do, a value again, we're looking at 1, so we're just going to get rid of it. Not going to put a 1 in there because we don't need it. You can if you want. What we've got is we've got this minus h. So here we've got a -3, so we're going to put -3 in. Well, minusing a negative is really just adding. Then we've got a plus k. Our k value is 1, so we're going to put that in for k. And we're going to get this for an equation. Now, some people may look at these equations and wonder, why is this always opposite and this always the same? Well, what we can do is we can put the vertex in for x and y, and what we'll get is we'll get it zeroed out. So I'm going to now show you that. On that last quadratic, we had -3, 1 as our vertex, and we had the equation y equals x plus 3 squared plus 1. What we want is we want this to equal each other. If we put the vertex in, we want it to equal out to be 0 because our vertex of the parent is 0, 0. Now this works for the quadratic and for the vertex form, or for the absolute value. So what I can do is I can put my vertex in for x and in for y, and when I do my math to this, I should get 0 on each side, or the same number on each side. So I can take -3 and put it in for x, take 1 and put it in for y. So 1 equals -3 plus 3 squared plus 1. What I can do is follow the order of operations. -3 and -3 give me 0. 0 squared is going to give me 0 plus 1 equals 1. 1 equals 1. Well, now I said the vertex was originally 0, 0, a y value and an x value. If you subtract 1 on both sides, you get 0 equals 0, which would be your y and your x of the parent function. So this comes back to this equation, the 3 and the 1 are going to zero out or put us back at the parent function using this. Okay, if there's anything about this video that you didn't understand, please pause, rewind, and watch again. Thank you.